So here we're going to talk about frequency distribution. So definition, a frequency distribution is a table that shows classes or intervals of data entries with a count of a number of entries in each class. Okay? The class frequency, the frequency F of a class is the number of data entries in the class. It's how many are in the class. So let's go through an example here. So say we have a class on the left and the frequency is represented by the letter F on the right. So the class goes from 1 to 5, and then we'll say that there's 5 of those. And then we pick up from 6 to 10, and we'll say there's 8 data points in there for that range. And then 11 to 15, and we have 6 of those. And then 16 to 20, and we have 8 of those. And then 21 to 25, there are 4 in that last class. So we call the number on the lower side, so this 21 here, the 16, the 11, the 6, the 1, these are known as the lower class limit. Okay. It's the smallest possible number that you could have in that class. Okay, so 21 can't get any smaller than that. And the number over here, the 25, 20, 15, 10, 5, this is the upper class limit. Okay? It's the greatest number that can be in that class. If we're bigger than that, then we're outside the class. All right? So this particular frequency distribution has 5 classes with corresponding frequencies. Okay? 1, 2, 3, 4, 5. Those are the 5 classes. Okay? So the class width, definition here. The class width we denote by CW. This is the distance between the lower class limits of consecutive classes. Now, what are consecutive classes? Those are classes right next to each other. So this class and that class are right next to each other. So the distance between the 2 lower limits, so here's a lower limit, here's a lower limit. So the class width is equal to 6 minus 1, which is 5. Okay? Now, it doesn't matter which 2 consecutive ones you pick, just as long as they're consecutive, you're okay. So if I pick these 2, then 16 and 21, when I subtract 21 and 16, I get 5 again, okay? So another definition is the range. The range is another important definition. The range is the difference between the max and min data entries. So with this frequency distribution, the downside of this is we don't know what the data points are between 1 and 5. All we know is that there are 5 of them. So maybe you could have the data points like 1, 2, 3, 3, 4, okay? That would be 5 data points that fall in the range, the class of 1 to 5. Heck, it could just be where it's just 11115, right? So you don't know what the smallest data point is, right? So you can't really calculate the range unless you're given the raw data, okay? So the range is calculated by taking the max minus the min, right? So the biggest number minus the smallest number, and that gets you your range, okay? Now, let's talk about how to make a frequency distribution, okay? Frequency distribution. So how do we make a frequency distribution? Number one, going to determine the number of classes. Okay, this is usually between 5 and 20 classes. Now, why do we have 5 to 20 classes? It makes it where it's easier to spot or detect a pattern. Easier to detect pattern. If there was only one class, up here, if we only had one class, all these were grouped into one class, and it was like from 1 to 25, and then it was, you know, however many there are there, looks like 16, 20, 31, then that's not a very useful frequency distribution, right? So it doesn't tell us very much information on how the classes, how the data is distributed. So the more classes, potentially the easier it will be for you to detect a pattern. But 5 to 20 is a good rule of thumb. Other thing you notice about the classes, they do not overlap. We can't be in one class and another class at the same time. So you look at this, if you have the data point 7, the data point 7 is only in this second class. It can't be in 1 through 5. It can't be in 11 through 15. It's only in 1. You notice we go from 10 to 11. We go from 15 to 16, 20 to 21. We never overlap our classes, okay? So very key right there. You don't overlap your classes. Now, number 2, and by the way, step 1, typically they tell you, I want you to make a frequency distribution with this many classes. So you don't even have to determine the number of classes, you just read what it tells you to set. Okay, so typically, you know, they might say, make a frequency distribution with 6 classes. Okay, so number 2, determine the class width. Okay, so how do you calculate CW? Well, to get CW, you take the range divided by the number of classes. The range divided by the number of classes. So that's the max minus the min divided by the number of classes. Now, the key to this part right here is you always round up. Always round up. Okay, this is the hard thing that students have remembering. Okay, so you always round up to the next whole number. All right, so say you get a CW equal to 8.2. I always round up. So I'm going to round up to the next whole number. That's 9. Say you get a CW equal to 7.8. Always round up to the next whole number. That whole number is 8. What if you got like a CW equal to 11? You always always round up to the next whole number. Round up to 12. Okay? So even if it is a whole number, you always round up to the next whole number. Okay? No matter what, always round up to the next whole number. That's probably the most tricky part in this making the frequency distribution. Always round up. Did I say it enough times? All right. Determine. Number 3. Determine the class limits. Okay, determine the class limits. So, how do we do the class limits? We start with the minimum data entry. Okay, and then we add the class width, right, to get the other lower limits. And once you get the lower limits, then use the fact that you don't overlap to get upper limits. Okay? So we'll work through an example here in just a second to illustrate this. Okay, so don't get too panicky. All right? Number four, so this is what you're putting on your little note card, right? So number 4, make tally marks. To find the total frequency F for each class. And then finally, number 5, you count those tally marks. And write out the number. For each class. Okay. All right, so let's do an example. Okay, so these are the 5 steps to create a frequency distribution. Now, here's my example. Make a frequency distribution with 7 classes, and this represents the travel times to work in minutes given below. Now, typically, these numbers are not in order, okay? But since we're going through this example for the first time together, I was nice and I put it all in order for you, okay? From least to greatest. So if it was not in order and you were going to start with the minimum, you would just go through the list, find the smallest one, write it down, and mark it out, okay? And then go and find the next smallest one, mark it out, write it down, right? That way you don't accidentally count the same one more than once, okay? It's easy when it's lined up from least to greatest because then you know automatically that there's 3 12s. But if it's all shotgun random numbers up there, then you've got to put them in order from least to greatest. So order from least to greatest. Okay? So it's already done for us. So here's what we're going to do. We are going to first have our class, okay? And then we're going to have our tallies, and then we're going to have the frequency, okay? So how do we get the class? Well, step 1 says determine the number of classes. Determine the number of classes. Number of classes is 7. Step 1 accomplished. Step 2, determine the class width. The class width is equal to what? It's equal to the max minus the min divided by the number of classes. Rounded to the nearest whole number, up to the nearest whole number. So we always round up. So what is it? The maximum value is 72. The minimum value is 3. So 72 minus 3 divided by how many total? 7. Now look, guys, you got to be careful when you type this in your calculator. If you do 72 minus 3 divide 7, you're not going to get the right answer. What are you missing here? You're missing a parentheses. So let's do it in our calculator. Okay, so calculator. So what do we have? We've got 72 minus 3, and I just hit enter, and then I'm going to hit divide by 7. And I get 9.85. Oh, what do? We always round up. So I'm going to round up to 10. So my class width is 10. Okay, class width is 10. How hard was that? Now determine the class limits. How do we determine the class limits? We start with the smallest, the minimum data entry. That's 3. So I'm going to put 3 here. And what do I do to get the next lower limit? I add 10 to 3. So if I add 10 to 3, I get 13. To get the next lower limit, I add 10 again. I get 23. To get the next one, I add 10 again. I get 33. And then 43. And then 53 and 63. Let me make sure that's 1, 2, 3, 4, 5, 6, 7 classes. Good. Okay. Now, what do we know? We know that classes do not overlap, right? So if this next class, this second class here, starts with 13, then the first class has to end with 12. Okay, so it's 1 less than it. Okay? And then if this one starts with 23, where does that one have to end? It has to end at 22. And so we continue this game, and we start to see a pattern. What's happening here? Look, if you notice here, all we have to do to get the next one is add 10, right? If we add 10, we get 22. Add 10 again, we get 32. Add 10 again, we get 42. Then 52, then 62, and then 72 right there. Okay? The reason we round up is because if we had not rounded up, we kept it at the 9.8 here, when we would have gotten to the very end, we wouldn't have gotten big enough to get to the 72, and then that last data point would have been left out of our class, okay? And then we would have had nowhere to put it. So that's the reason we do it, all right? So now we've got that. Let's make tally marks for each data point. So the first class goes from 3 to 12. So 3 to 12, I got 1, 2, 3, 4, 5, 6, 7. Okay? 1, 2, 3, 4, 5, 6, 7. The next class is from 13 to 22. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. All right? The next one, and the reason you're doing tally marks here, people, is because if they're not in order, then it's a little bit more challenging to just list them out. So when we tally mark them, that's because we're like marking them out as we go. So like 23 to 32. So that's 1, 2, 3, 4. Looks like 4. 1, 2, 3, 4. Okay. Then we have from 33 to 42. So that's 1, 2, 3. Okay, so 1, 2, 3. Now we've got 43 to 52. 1, 2, 3 again. So 1, 2, 3. And then 53 to 62. That's 1, 2. Looks like just 2. And then 68, 70, 72. That's 3. So what do we have? We have 7, 6, 4, 3, 3, 2, 3. Okay? So now we have just completed our first frequency distribution. All right? So we have, for a frequency distribution, you have the class, and then you have the frequency. So 3 to 12 has 7. 13 to 22 has 6. 23 to 32 has 4. 33 to 42 has 3. 43 to 52 has 3. 53 to 62 has 2. And 63 to 72 has 3. And so this is my first frequency distribution. All right, hopefully that's helpful as you go through and making your frequency distributions.